And so I should probably give a little overview. We're going to start with Andrew Carpenter. He's going to give us an overview of agriculture and carbon, both emissions and sequestration potential. Then we're going to go to Caro, Roszell and Jeremy Barker-Plotkin, and then we're going to go to Ryan Fitzbeauchamp. And I think, but before that, Rachel's going to maybe give some context to why we are highlighting the projects that Jeremy and Ryan have been doing on their farms. Okay, I'm muting. I'm done.
Thanks, Caleb. It's good to get the lay of the land here. So yeah, I'm really excited. Sorry. I'm really excited to be a part of this session and to hear what folks have to say. As Caleb mentioned, Jeremy and Caro and Ryan are all part of a program that Caleb and I help coordinate called the Climate Adaptation Fellowship. And it's a one-year fellowship program where farmers work together with ag advisors of all stripes to do some close looks at working farms, think about climate change, think about what we can do to better address greenhouse gas emissions, and think about adaptation on the farm. And what we can do to kind of help educate our broader community about these topics and issues, because it really is, as I think we all know, very timely, and we don't really have a lot of time to waste. So I'm happy to follow up with anyone individually who's curious about the program, but like I said, or like Caleb said, the real meat of this session is in our presenters, so I'm ready to pass it off.
All right, Andrew, you can take it away whenever you're ready. I don't know if Andrew's trying to speak, but I can't hear him yet.
Why? Because I put this thing up. Can you see the full screen without the notes? Okay, great. So yeah, I've got it's a big topic to cover in 15 minutes, so I'm gonna be kind of skirting through this quickly. So I want to talk about kind of the pathways of carbon in soil, what happens to carbon in soil, how long-lived it is, that kind of thing. And so to start with, we have this magical process of photosynthesis that's able to collect and use CO2 from the atmosphere, water, and make more complex biomass with it that has some inherent biochemical energy in it. From that, these plants die. They generate root exudates that are in the soil. When they're growing, we poop, we die. All this stuff ends up, this biomass ends up on the soil or in the soil in one form or another. And when it does, it's then subject to microbial action. The bugs get very excited when they find some organic matter that they can derive some energy from. So they oxidize that organic matter. They're deriving energy from those biochemical bonds in the biomass. And then during that process, they regenerate. So they create more microbial biomass. They also transform a lot of that organic matter back into carbon dioxide and water, which a lot of that carbon dioxide then goes off into the atmosphere. And then what's remaining is actually people aren't referring to it as humus as much anymore, but stable organic carbon that sticks around in the soil for a long period of time. So in that process, as a rule of thumb, it doesn't always work this way, but about a third, when organic matter is added to soil, plant biomass in the form of manure, living beings, anything that have died, approximately 2/3 of that carbon embodied in that biomass is going to go off into the atmosphere, and about a third of it is going to be captured in the microbial biomass or those more stable organic carbon compounds that stay around and create the more mature organic matter in soil, the longer lived soil carbon. So in that case, from that perspective, we have this natural pump that is taking carbon dioxide out of the atmosphere, and ultimately a third of that or so is persisting in the soil, 2/3 of it's going back into the atmosphere. So over time, well, I want to talk first real quickly about just amounts of carbon. If you look at the amount of carbon in soils, 2,500 petograms approximately, compared to the amount we have in the atmosphere, which is about 760 petograms. You can see that in terms of actually capturing some of the carbon that's in the atmosphere and trying to sequester it in soil, we actually have an opportunity. There's the scale of what's in the soil is very large compared to what's in the atmosphere. But we have the ability essentially to change that balance one way or the other. If you think of all of the, if you think of the Great Plains and you think of all of that windblown glacial silt that deposited there after the last glaciation, we've had millennia of grass growing out there, grass growing, dying, growing, dying, the root biomass growing as the plants grow and essentially accumulating in soil. We have this, again, this natural pump, and out there it's a great example of meters in some cases of this nice, thick, organic matter rich topsoil. One of the things that has happened with that is when you subject soil with organic matter to heavy tillage, you're essentially incorporating air and creating conditions where microbes now have access to a lot of that carbon that's been stored there, and they then oxidize it. And so you lose a lot of that captured soil. We have this natural pump, but some of the things that we can do agriculturally can actually reverse that pump. And so we send a lot of that carbon dioxide back into the atmosphere with certain cultural practices. So if you, again, looking at the Great Plains, this is from NRCS. This is a graph over time of presumed soil carbon layers. And you can see it looks like that contemporarily we're at about 60, we have about 61% of the carbon that in those soils that we had back in 1900. So, approximately 40% of it is lost. And that you think of the scale of the plains, that's a huge amount of organic carbon that's been then converted to carbon dioxide and gone back into the atmosphere. There are a lot of different techniques agriculturally that we can use in order to try and capture as much of that carbon as we can, and importantly, not lose the carbon that's there. There is a sort of equilibrium that can be reached with carbon in soil. So soils that are already rich in carbon, it's actually pretty hard to accumulate a lot more carbon in them. But disturbed lands are a great example of areas where you can sort of start from scratch and start to build carbon and sequester carbon, both from adding organic matter material back to the soil, but also just by developing a healthy soil ecosystem, essentially jump-starting a new soil building process that then has the ability, again, to start this pump over where you're accumulating organic matter in soil because you're speeding up the process of biomass accumulation. Agricultural land, there are a lot of things we can do. Adding organic amendments is sort of the type of thing that I'm most focused on, but it's only one of the potential tools out there. But certainly building soil health and fertility with organic matter-based soil amendments rather than using commercial fertilizers can do a lot to help accumulate organic carbon in soil. Based on a literature review that we've done recently, that we use in a greenhouse gas emissions model for agriculture, we found that approximately the return that you get on and this is averaging things, it changes a lot from material to material, but you can accumulate the equivalent of about 0.66 metric tons of CO2 for every dry metric ton of organic matter-based amendments that you're adding, things like manure and compost. So that's one element. Adding as much of our organic matter-based byproducts as we have back to the soil does help sequester carbon over time. It's going to change based on the soil that you're adding it to. If we look at the impact of processing organic waste on carbon, different steps will have the potential to change the amount of carbon from that initial source of biomass, manure, whatever it is. In the end, they all end up being about equivalent. So if you directly land apply manure, you sort of go back to that rule of thumb that I was talking about, where maybe a third of the carbon that you're adding may persist in the soil as longer term soil carbon, whereas 2/3 of it is likely to be oxidized and go off into the atmosphere. When you compost, essentially you do a lot of that work, that microbial oxidation occurs in the compost pile rather than in the soil after adding it to the soil. So you're sort of you're speeding up that process, but the end result is about the same. When you add that compost to the soil, more of the carbon in the compost is going to persist, but you've already lost a lot of it during the composting process. Anaerobic digestion, we work with a lot of farms that do anaerobic digestion throughout New England. That's it's sort of somewhere in between the two, direct land application of fresh organic matter versus applying composted organic matter, where in this case, some of the organic carbon is transformed to methane that's captured in an anaerobic digester. And then the remaining carbon in the digest state is going to add carbon. But again, if you look at it from beginning to end, from prior to digestion to what you're actually adding to the soil, it's going to be approximately the same. About 2/3 of that carbon dioxide is going to be lost. In this case, some of it to methane, some of it to CO2 to the atmosphere. Pyrolysis is a little different in that in the pyrolysis process, you're actually, so if you're pyrolyzing biomass, you're actually changing the structure of the carbon. So you're moving from sugars, starches, proteins, cellulose to a graphite-like structure that is very resistant to microbial oxidation. So that does change this equation a little bit, in that when you're adding biochar to soil, if it's been properly pyrolyzed, it's actually going to be very resistant to change, and a higher percentage of that is going to remain as recalcitrant carbon in the soil. One of the things, though, is in the process, we have done some greenhouse gas emissions analysis and some pyrolysis projects. You actually lose some of the CO2 and the biomass during pyrolysis itself. So in the end, it doesn't look too different. It is going to change depending on the actual process. But so pyrolysis changes things a little bit. I'm not going to, how much time do I have left, Caleb?
I lost track of when we started, but we probably don't have too much for biochar. That's my guess.
Okay. So one of the things that is tricky with carbon accounting and greenhouse gas emissions accounting when it comes to agriculture is that none of this is really black and white. Like I say, the amount of carbon that you add to soil is going to change based on the soil that you're adding it to. If we're adding carbon to my own vegetable gardens at home, where we throw copious amounts of all the leftover waste that I have in the office, I'm not going to see much of a gain because it's already got a lot of carbon in that soil, and areas that have been disturbed, they're going to do a better job at sequestering more carbon from the start. But there are all kinds of these sort of trade-offs that occur that make it hard to make blanket statements. And if you're looking at the big picture, as opposed to just carbon sequestration in itself, but more and step back and look at, well, how much fossil fuel are you putting into the process, your processing of that material, applying that material, transporting that material, it starts to change a little bit. So fossil fuel inputs make a difference. A bigger difference comes from conversion of that organic carbon to methane. If that methane isn't captured, that methane has a global warming potential 28 times that of carbon dioxide. So a little bit of methane being lost in the process can really skew your balance in a greenhouse gas emissions accounting. And then even more than that, converting when that nitrogen that's in that organic byproduct is converted to nitrous oxide and goes off into the atmosphere, that has the global warming potential closer to 300, 265 or so. So if you have a process that is somehow conducive to having nitrous oxide emissions, a wet process with a nitrogenous material, then again, you can skew your results quite a bit. When you're land applying organic matter-based material during the storage of a wet material, you can have nitrous oxide emissions, you can have methane formation, so that then when you break into those piles, you're letting methane off into the atmosphere. When you're applying manure, say a wet material, wet manure to fine textured soil, you also have conditions that are conducive to generating nitrous oxide. In composting, you have moist conditions, you're gonna generate methane potentially in those piles. If you don't have a biofilter over the top of them, you get a fair amount of methane that can be released during the composting process. And it's the same with nitrous oxide if you have a low seed-end ratio material that you're composting. Like I say, agricultural practices are a big deal, and one of related to carbon and the whole carbon balance. One of the biggest really seems to be reducing tillage. So changing your process from, especially if you're using deep tillage, aggressive tillage, to minimizing that makes a big difference. Again, you're not going, when you're minimizing your tillage, you're not introducing all of that air that gets the microbes very excited, that then allows them to attack some of this organic carbon that's otherwise not available to them. If you look at the carbon markets that are out there, and farmers that are taking advantage of actually getting carbon credits that they can trade, most of these to date have been based on changing tillage practices. But then there also cover cropping makes a big difference. Keeping as much green material, as much material growing and generating biomass throughout the year makes a big difference, because you're getting not only more biomass, but you're getting the root exudates as well. One of the bigger farms that we work with switched to no-till 14 years ago. We did kind of a rough assessment based on organic matter testing of those soils on that farm, and found that over those 14 years, they've increased their soil carbon by about 34,600 tons on their 2,200 acres. So on a landscape scale, this kind of stuff can make a difference. Unfortunately, all of these things have drawbacks potentially. One of the things about no-till is it makes it harder to incorporate manure, and sometimes, especially if you have a liquid manure system, you're not able to incorporate it. You have the potential to generate a little bit more nitrous oxide emissions. So that's not to say that that's bad, that negates all of the gains, but it's more to show that it's a very complex calculation overall. And there is, if you look at, so especially not in the published literature, but if you look at kind of more gray literature, or worse yet, people that are promoting a certain technology, there is a lot of cherry picking when it comes to greenhouse gas emissions accounting. It can be very frustrating, because it's a very complex issue. So in summary, Soils do represent a large pool of carbon. We have the potential, by changing management practices, to discourage intensive tilling, by adding more of our waste materials back to the soil, by keeping green cover for longer times of the year, to actually help reduce climate change. Not an end all and a be all, but we can really make a fairly big difference on a landscape scale. Not all of the carbon that you add to soil in organic matter byproducts is sequestered there, but there is a significant portion that can be, given the right conditions. But importantly, in looking at the bigger picture, carbon sequestration itself is only one part of the equation. So if you're sequestering a lot of carbon, but in that process, you happen to be creating the conditions for a lot of nitrous oxide emissions or methane emissions, then you might not be helping out in the long run relative to the bigger climate change picture. So that's basically it. I wanted to give you an overview of kind of some of the complexities and some of the issues that go into accounting for carbon as it relates to agriculture. And I'd love to have questions.
Yeah, thank you, Andrew.
Yep.
The first question I see in the chat is if you have any good examples of biofilters that can reduce methane and nitrous oxide emissions in a turned compost pile system.
Yeah, I mean, for a turned windrow, the best thing to do is to add just a small cap over the top. So after you do a turn, keep on site some finished compost that you can sprinkle over the top, and that is really effective. Usually, somewhere between 10 to 16 inches. It's a little extra work, but it does make a big difference in terms of those emissions. That's more related to methane, nitrous oxide. It's more important to keep your carbon to nitrogen balance not too heavy on the nitrogen end.
Great. And this one's less specific, maybe more of a general question to everybody, but someone was wondering if they can get PowerPoints or slides. The recordings of this presentation will get mailed out, but I think folks may be wondering if they could get like a PDF copy. And I imagine that's going to vary presenter by presenter, but.
For me, it's fine. Yeah, this is available. I can transport it to, or edit, whatever, make it into a PDF and send it to anyone who requests it.
Great. I would normally try to drum up some more questions, but I do want to be saving some time at the end for everybody.
Yep.
So let's move on to Jeremy and Caro.
Oh, let me stop my share.
All right, can you all see that? Awesome, great. So I'm just going to go ahead and jump in, but our slides, or our talk is called Organic No-Till Farming, a Response to Climate Disruption, the First 2 Years of No-Till Transition at Simple Gifts Farm. All right, just get my slides to advance. All right, so I wanted to start by addressing some of the climate change projections for our region. Regionally, climate change is expected to look like this in the Northeast: an overall gradual increase in frost-free days, days above 90 degrees Fahrenheit, total precipitation volume, and an increase in humidity. But precipitation is expected to be concentrated into more extreme precipitation events with higher frequency in the winter and early spring months, while the summers are expected to include longer periods without precipitation. So more precipitation overall, but fewer heavier rain and storm events and more drought. So really challenging. Now, Dave and Jeremy and his business partner, Dave, have already been doing quite a laundry list of the practices recommended in the USDA's Climate Adaptation Resources Manual, such as cover cropping and on-farm composting and integrating livestock and crop rotations. But even still, they experienced 2 really concerning extreme weather events in the last few years. First, a serious drought that threatened their well pressure, and an extreme precipitation event that caused erosion on the farm. So combined with a strong desire to be part of the solution in terms of mitigation, they decided to take the further step to reduce tillage on their farm, which is a really challenging thing to do for an organic farm of their scale. So Jeremy's going to take it from here and talk about some of the ways that they're approaching no-till on their farm.
Yeah, thanks, Caro. Yeah, so organic no-till, we see it as a, it can be an answer to both adaptation and mitigation to climate disruption. So adaptation being, things that you can do to, adapt to what's happening with the climate, and mitigation being things that you can do to help reduce climate disruption in the future. So, organic farming systems, the soil fertility is based on soil health. Soil health equals soil carbon. So, right there, you are, hopefully sequestering some carbon. And the fact that you're, looking for a more healthy soil, a higher organic matter, the organic matter in the soil can act as a sponge and absorb more moisture when it's wet, and need less moisture when it's dry. Kind of, acts as a sponge and soaks it up. And we've seen really more than just like a couple events of this type of, the weather that we've seen over the last several years. We had the wettest July on record here in Massachusetts. This year we had an extremely wet year in 2018 as well, and we've had a lot of periods of drought around those. And I think it was that real wet year in 2018 when we decided to go ahead and experiment with reducing tillage on our farm. And I think it's a good story that we can tell. It's important to be communicating about this with the public. It's good for us as a kind of public relations move, and it's also, just a good educational thing for people. So you can hit the next slide, Caro. So no-till goes even further than, as Andrew mentioned, goes even further to increase soil health. And this slide has some of the stuff I just talked about. But yeah, in thinking about going no-till, really weed control is the thing that I thought about the most. In theory, you've got less soil disturbance and you've got fewer weeds. But our entire cropping system is built around cultivation and being able to control weeds by cultivation. So it really takes kind of redoing how we do everything in a sense to go to a no-till system. And I think we had some resistance because it's hard to imagine going to a really changing everything. So we can hit the next slide. We've got what we came to, and this is still very much a work in progress, but we've got kind of two different no-till systems that we're working with. One is a more intensive system where we're shrinking the scale of what we're doing, and we're using compost mulch and then tarps for weed control. And I think when you see what's out there for what other people are doing, there's kind of the postage stamp size market farm model where people are successfully developing no-till systems. And then there's kind of more extensive systems which really depend on big equipment, and like maybe if you're doing several hundred acres of sweet corn, you can buy yourself a no-till planter. But for a kind of mid-sized farm like we are, we didn't really see a way to do that. But the more extensive crops that what we came to was a transferred mulch system it's based on ideas of Jan Hendrik Krop out of Germany. And so we started the more intensive system in 2020, and then in 2021 we started doing this heavy transferred mulch system. We got some help with equipment that you're going to see from MDARS, the Massachusetts Department of Agricultural Resources. They have a grant program called ACRE that we got some equipment from them. So again, next slide. So this is what the intensive system looks like. So we managed this field with a tractor to start out. We put down compost mulch with a manure spreader, and then the whole rest of the season we were just rotating around within that area and kind of planting salad greens with that Jang cedar that you see. Planting salad greens, harvesting them, and then tarping and planting again. So we went through the field 3 times in a cycle like that, and we're also planting much more intensively. So we're getting 10 rows per bed as opposed to previously we did 5 rows per bed. So we're essentially shrinking that production of salad greens. You know, there were a few other things that fit into this system to 1/6 of the land that we used before. So you can hit the next. This is kind of a graphic of these colored blocks. The one on the left is what we did in 2020, and then the one on the right is what we did in 2021. Our fields are 300 feet long, or our blocks are 300 feet long. The tarps that we have are 32 by 100, so that covers, and we have 6-foot beds, so that covers 5. One tarp covers 5 beds by 1/3 of a bed long. In 2020, we broke that field up into shorter little chunks. So we might have started, you know, on that blue section to the upper left, planted there, and then planted in the yellowish section to the upper right, and then moved to that green section. And you know, when we got done with the crops in that first blue section, we would put the tarp down there again. That worked out pretty well, but we ended up like in between those 100-foot sections. We had big chunks of weeds there where sometimes the tarp wouldn't quite cover. And then those blocks in the middle, we're not doing a lot of tractor management, but we really couldn't do anything to the middle blocks in that section. So we moved in 2021 to more of a system where we did a whole 300-foot long. So this is 3 tarps long, the blue section in the 2021 picture, and then the orange section is 3 tarps long. And we've got kind of more ground in this pattern. So we would do this blue and yellow block, and then we'd move somewhere else, and then we'd move back to this a little later in the season. Some of the concerns we've got out of this system, I think actually, could you hit the next slide, Caro? Got things a little mixed up, but you can see like our weed control is pretty good. This is that system. Yeah, some of the seeding into that compost and into the dead cover crop. So, you know, we would have harvested that salad mix in the foreground and then just put a tarp on it and killed it. And there'd be still some dead salad mix there when we're coming back to seed. You know, that if I kind of raked it off, it did a little better, but sometimes it was a little tricky. More concerning, I think, the second year in this block, we're starting to get a few perennial weeds coming in. I think, you know, we've got like real short rotations of shallow rooted, you know, quick growing crops. So, and then a very short tarping period. So, you know, the perennial weeds, if it gets established, that short period of tarping doesn't quite kill it. So we're starting to get a little bit of buildup of that. I also think just in terms of the soil health, getting a longer term cover crop in there would be important. So we're trying to, I think we're going to be rotating this section out this coming season, and trying to get some kind of more long-term rotations. We did see some compaction, like the crops were kind of growing just in that little section where the compost was, and we saw it especially with carrots. They didn't quite get down. We had lots of little short fat carrots. So we can hit the next slide. This is another example of this intensive system. This was from 2020. We transplanted these crops directly into a compost mulch, and this I think was after this was the second round. So we had grown lettuce this way, tarped it, and then this is in the fall. You can see the foliage there. This is in the fall. So yeah, again, like weed control is pretty good there. Not, and this was, I think, no hand weeding happened in this section. You can hit the next slide. This is how we transplanted into this system. We modified our water wheel transplanter with these spikes that we bolted on to the transplanter spikes. So that's able to kind of punch down through the compost mulch. And we also use this for the more extensive mulch system. We've actually modified this transplanter further this year, and we've got 5 rows that we're planting, because if we're not cultivating, we don't have to worry. That 3-row system was to allow room to cultivate for weed control. So moving on to our extensive system, that's me, and there's Dave in the orange shirt, Dave Tepper, my farming partner. So we cut mulch elsewhere, and I'll show you. I've got a little video of the equipment that we used. Lay down a heavy layer of mulch, and then transplant in with that spiky transplanter. Do the next slide. Here's the video of how it works. So this was all these. There's 2 pieces of equipment here. This is a collection flail mower that cuts the cover crop and kind of gathers it up in a hopper in the back. And then we dump that hopper into a manure spreader, and then are able to spread that over the field to plant into. The grant also helped us out with a no-till a no-till grain drill, which is great for getting cover crops in after we seed. So there, Dave is dumping. This piece of equipment is so cool. We were so psyched when it showed up, and then we're spreading it on the field. Yeah, some of the things we learned this year. The amount of mulch that you have to put down is incredible. And we were going. And so here's that spiky transplanter going right into that mulch. Yeah, the amount of mulch that you have to put down is pretty extensive. Think we're going back around. Stop. Can you get us to the next slide? So yeah, so this system definitely, we had I think a steeper learning curve. That compost mulch system was pretty simple. There's some things to work out. The heavy duty mulch were definitely climbed a steeper learning curve this year. So transplanting into that mulch, the soil kind of, well, first of all, when you poke a hole, you're kind of poking some of the mulch down in there, which wasn't such a problem with the compost mulch, but with this stuff, that would get in between the plant and the soil. And then we found that soil kind of made a hole like this, rather than, if you've got a freshly tilled soil in your water wheel transplanter, it kind of makes soil kind of flows in there and makes like a muddy hole. So you put your plant in there and the mud kind of dries up, but around the plant. With that, the no-till hole, it's a hole like this, and the water drains out, and then you've got a hole, and you've got your plant kind of sticking in there, and it doesn't really get the root to soil contact. So we figured out that we just needed to have our crew spend a little more time and kind of pull the mulch out, and then make sure that the plant was kind of squeezed in there. We also had some, we think it's nitrogen tie up. Some of the plants, sometimes they would just sit there. And we ended up kind of feeding them a little bit of Chilean nitrate through the drip tape, and that seemed to perk them up. So we think, especially where we're growing rye and then mowing it and then putting mulch down on top, we're adding plenty of nitrogen in that mulch that we're adding, but the rye, as it's growing, is kind of sucking all the nitrogen out of the soil. So that yeah, it looked like the plants were a little bit starved. And I think we can get around that by by that drip tape trick, or also just putting a little more nitrogen in the transplanter water. Yeah, then the timing of cover crop mowing and the quantity of mulch, we need a fair amount of work on that. It's especially tricky, in May when we're doing a lot of our planting of fruiting crops. The places where we have rye and we're mowing it and are going to put these fruiting crops into, the rye wasn't necessarily all ready to get killed by mowing. So we're actually have a lot more oats and peas that we're going to be planting into this coming year. And the rye, we're going to be more kind of cutting that and putting it on the sections that are in oats and peas. And then like probably mid-May, we'll mow rye and maybe tarp it a little bit because it won't be ready to mow kill. And then like late May and June is when you can, at least here in Massachusetts, is when it seems like the rye will mow and then die. So next slide, I think. Oh, and it's on to you, Caro.
Yeah, I'll just say briefly, I think we're running low on time, but so as part of my my climate adaptation fellowship partnership with Jeremy, I conducted some soil health assessments and sampling on the fields that were relevant to these practices. So I identified a set of fields with Jeremy to track based on two main soil types on their farm, Sudbury fine sandy loam and Hinckley loamy sand, and based on management. So I was looking at tilled fields, the intensive no-till blocks, representative ones, mulch applied fields, and mulch harvested fields. And I used the NRCS Cropland Infield Soil Health Assessment Protocol to evaluate those 6 fields. And on the side here are those data that I collected. So soil cover, surface crusting, soil hardness, etc. I also collected Cornell soil health tests on 4 of the fields. And we're currently seeking, funding support for the farmers and for myself to continue tracking those soil health indicators over time and to expand our lab-based testing on those fields. This was just 1 year of data collection, so there's really no conclusions to draw at this point, except to note a few unsurprising correlations, like the sandy loam fields had higher soil health indicators than the loamy sand fields, which we expected. And that there were the higher penetrometer readings were associated with clady soil structure observed. Overall, the biggest soil health challenge at Simple Gifts Farm is compaction and soil structure, since pladiness, massiveness, and high penetrometer readings were prevalent across the fields assessed. But we do have some questions. I hear a lot when talking to farmers about how they experience a period of challenges when they first go no-till. And one of the primary challenges is hardness. This is backed by research that shows that no-till soils tend to have higher bulk densities, which is expected. Once the soil is no longer being mechanically aerated, we see some compression. Yet at the same time, we hear from long-term no-till farmers who are really extolling the loose workable soils that they've achieved. So farmers are told that no-till improves soil structure, porosity, and reduces compaction. But this is clearly not the case for many farmers in their first few years after going no-till. So I don't know of any good resources or detailed information on how many years it takes for a harder early no-till soil to transform into that beautiful structured soil we hear so much about, and what changes the soil goes through on the way. So it's something I'd really like to be able to track with Dave and Jeremy over the next few years. The other thing we'd really like to track going forward are the nutrient and soil organic matter dynamics of the transferred mulch fields. Especially, do the fields that are harvested for mulch show a positive, neutral, or negative nutrient and organic matter impact? And what's the nitrogen release timing of different mulch thicknesses and mulch sources, and also, you know, maturity of the mulch crop? And we're also looking at options. We are looking at some options to fund some of this data collection going forward, so we can keep tracking some of these things. So just to close, there are a few, oops, having trouble advancing. There we go. Just a few resources we wanted to flag for you for organic farming, climate adaptation, and transferred mulch systems. And I'll pop some links to these resources right into the chat. So I think that's what we have for you.
Thank you so much, Caro and Jeremy. I will start to unpin your videos and get ready to pin Jeremy's. But there was one question, and it looks like maybe there might be more coming in. But the first, and I think this might hit on some of what you're talking about, the nitrogen release dynamics. Someone was asking, what about using a legume for the transferred mulch, I assume, instead of rye?
We are putting in a lot more overwintered legumes this year. Some of the, I guess, you know, we had a lot of rye. We tend to end up with rye when we get out of a field kind of later in the season, but we're in better shape this year. And actually, that no-till transplanter, which I didn't show you a picture of, but that's been a big help for, especially as wet as this fall has been. It's really helpful for getting the cover crops in as soon as we got a crop out. Just mow it and put the cover crop right in.
Jeremy, I wonder what kind of rotation you do on the fields that you use to harvest the transferred mulch. After you cut and harvest that rye or other crop, what do you use that field for?
We have planted sorghum Sudan grass as kind of the next cover crop on some of those fields. So we're thinking that some of our fields might stay in kind of mulch producing for a little while and go through a cycle where we're planting, you know, it's got rye, you know, rye and vetch or winter peas that get harvested off, and then sorghum Sudan and soybeans or sun hemp that then get again harvested off, and then maybe go back into rye and a winter legume. But I think this is actually kind of a big question for us, is we've got these pieces that are different than how we used to do things, and so we haven't really quite changed our rotation or figured out like what our new rotation should be. So that's a big open question still, I think, at this point. I guess I referred to it too with the intensive system, where we want to, rather than just leaving that in intensive cropping continuously, we want to take it out. And we haven't quite figured out like what the sequence is.
And something I'm curious to see, Jeremy, is how you guys work with, because Dave and Jeremy also rotate livestock through their vegetable fields and graze their cover crops. So I'm curious to see how that will also integrate.
Yeah, and right now Dave's looking at buying hay because we've cut all our fields for mulch. And earlier this year, he was like, "Oh, it's so wet. I've got all this pasture ahead of me."
Oops.
Yep.
Well, I think, yeah, I also would just chime in that even if it was a legume that was nitrogen rich, your plants still can't access it until that plant matter breaks down. So you still have a time delay, and they're going to be mostly using the nitrogen that's in the root ball that they're in at transplant.
Jeremy, one thing I was curious about is you mentioned how heavy the rate is for the mulch. What, in terms of acreage, how much that the mulch that you're putting down in any one location, if you were putting down in an acre, say, and you were getting it from a rye crop, would that be 1-to-1
Roughly
acreage,
like
or
3 or 4 to 1.
so
is
it's
what we
really
were
high?
doing. And that wasn't really getting perfect weed control. Like
Yep.
it was pretty good weed control when we also used weed mat. But it's not the whole year's production of 4 to 1. It's, that's like the spring.
That portion, that's
if we're
into
mowing
which the
rye,
crop is
it's just,
growing, yeah.
just the spring portion. So that's, I think, where the sorghum comes in. We're thinking that we might try and like pre-mulch some stuff also.
Yeah. Thanks.
Yeah.
All right. I hope everybody's writing down your thoughts and has lots percolating. I think we'll have some good discussion at the end. But let's move over to Ryan to talk about what he's been playing around with at his farm. And if anybody was at Farmer to Farmer last year, hopefully you got to see Ryan's great presentation, or sort of our virtual farm tour.
Okay, thank you for unmuting me. Let me get back, see if I can get to the beginning of my slides. Okay, so I'm Ryan Fitzbeauchamp from Evening Song Farm. Our farm is on Abenaki ancestral land in Shrewsbury, Vermont. And I'm going to be talking about high residue no-till production on a small scale on our farm. So to start with why our farm was interested in high residue no-till production, we were looking to increase our soil coverage for erosion control. Our farm's on a slope, and managing for erosion was one of the biggest constraints in our production. We wanted to see if we can reduce the weeding and overall labor required for crop production. We wanted to have a management tool that we could use for long-term weed seed bank reduction. And we wanted an opportunity to maintain and improve our soil structure. And all these goals kind of came out of our previous cropping systems, where we found that we weren't doing as good a job as we wanted to with all of these things. And so we were kind of seeing these problems increase over the few years that we were using our land, which for several decades before we used it was just a mowed field. And then seeing these issues with erosion control, weed proliferation, and decrease in the quality of our soil structure, that was a big drive for us to look into high residue no-till production. And then we wanted to see if we can meet these goals while also growing a cash crop, since our farm is fairly land limited. And I should add, as I start this presentation, my thanks for the Climate Adaptation Fellowship, of which we got to be a part this year, and Rachel Schattman, who is our advisor for that, and Becky Madden, who was our provided technical assistance for us. And so to start, I'll just kind of do a brief overview of what the system looks like on our farm. So starting in the fall, we seed rye or a mix of rye and vetch. And then in early to mid-June, the rye grows to the pollen shed stage. At that point, we flatten the rye. The picture on the left shows rye that's been flattened, and the picture on the right is rye that is mowed, the way we used to manage rye. And so to flatten the rye, the way that works with the equipment that we have is I'll drive my tractor with the bucket on the same direction over a zone that has rye in it. I'll apply a little bit of down pressure to the tractor bucket, and that's a quick and easy way to flatten it. So then the next step is to apply fertilizer if necessary. We cover that area with the black tarp. We find it takes about at least 10 days for the rye to kill. So we plan, once we're covered, we plan that we need 10 days to be able to kill the rye at a minimum. And then when we're ready to transplant, into that zone will remove the tarp, and the dead cover crop residue will be underneath the tarp. So then this gives us a transplant window of mid-June to mid-August to set transplants into this soil. And then 2 to 6 weeks planting is the opportunity to rogue weeds. Since obviously there's no cultivation that's able to happen in this kind of system, any weeds that emerge in this need to be, you have the opportunity for 2 to 6 weeks after to deal with them. The neat thing about this is, for the most part, we have very little weeds emerge through this system, even though our weed seed bank is, it varies, but can be somewhat high. So this picture shows broccoli that's been transplanted maybe about 3 weeks prior to this photo being taken. And you can see there's a little dandelion in the bottom right and a few other annual weeds that are coming up, but very, very little. I'm not able to get to the next slide. Here it is. And then the last step, of course, is to harvest the crop. So that's a basic overview of the system. And then I wanted to talk in a little more detail about the kind of what we've learned about using the system and how the kind of details that we've discovered to help make it work well on our farm. So the first one is that that cover crop preparation and establishment is a really important part of this. So the soil needs to be free from compaction before the cover crop is established, using whatever tools you have for that. There needs to be little or no perennial weeds in the soil. The mulch in this system does a really good job of controlling annual weeds, but is not able to control perennial weeds. And then the rye and vetch need to be densely seeded in the system. And then cover crop termination, we discovered that it's important to sufficiently flatten the rye before tarping. The picture on the left shows a field that was flattened fairly well. The picture on the right, the rye kind of sprung back up, and I had thought that putting a tarp over it would sort of slowly help it settle down, but that's not the case, and it's much more difficult to transplant into something like the right. Fertilization is the trickiest part of this, and the part that I have the least understanding in. But what we did for the climate adaptation fellowship, Becky and I looked at nitrogen availability in the system. And a big part of what I was interested in is to see how nitrogen would be released in a system like this when it's applied but not incorporated. And so this year, Becky came out about once a month to take pre-side dress nitrate tests across our fields and throughout the growing season. One of the bummers about this year was that the vetch that we had seeded in the fall winter killed. I think from the warm November that we had, it made it get a little too lush and it wasn't hardy to withstand the winter. So we only had rye in our fields this year. And I was hoping to see what kind of effect the vetch would have and to see if having vetch in the system would reduce or eliminate the need to apply nitrogen to these fields. So we did apply 5-4-3 fertilizer. In some of the zones, we applied them before tarping, and in some of the zones, we applied it after the tarps were removed. And one thing that was clear from the kind of scattershot data that we took this year is that applying the fertilizer and then tarping rapidly mineralized nitrogen during 4 weeks when the tarp was on that field. So when we applied nitrogen to a field like this and tarped it for 4 weeks, there was a lot of nitrates available when that tarp came off and plants went in. And those nitrate levels kind of leveled out over the course of the season, but we probably lost a lot of nitrogen. We probably over applied. So it was clear from that fertilizer incorporation is not necessary to get nitrogen available to plants from the fertilizer. And then, of course, since the vetch winter killed, we don't know what kind of difference it would make if vetch was grown in the system. And then one idea that Becky had that I thought was really interesting is to apply fertilizer in a band right in the rows where we're planting instead of broadcast across the whole field. And so that's something that I'm just curious about as a way of potentially reducing our fertilizer application rates. So another thing that we tried that we learned a little about is using clear plastic for cover crop termination. This is another way that you can kill the cover crop once it's rolled. And the clear plastic is very successful at terminating cover crops quickly when you have sunny days and temperatures in the 80s. A day or two of those conditions and the cover crop will be very thoroughly killed and ready to plant. So it's a way that you can potentially have earlier transplanting in the system if the weather is right. However, the clear tarps are not as reliable at killing any annual weeds that may be in the understory. So if there's little summer annual grasses that may have germinated in the rye and are growing underneath all this residue, many of those will still survive the clear plastic. And so we would only consider using clear plastic if we were using that on soil that had a really low weed seed bank. So transplanting, in our first year that we tried this, we grew this on 1/10 of an acre. And we had a lot of success that year, but transplanting was definitely a bottleneck in the system. It was difficult once that rye was rolled down in our soil to be able to loosen the soil enough to get a transplant into the soil. And so we really liked every other part of the system from that first year. And so we wanted to find a way to make that part of the process more efficient. What I would say, if for starting out, for like trying the system on a smaller scale without investing in much equipment, is this tool is really useful. This is something that Natalie Lounsbury recommended. This is, I think, maybe where I originally learned of the system in a presentation that Natalie gave. And she recommended this tool as a way to just poke a little hole in the soil that a transplant can go right into. So we purchased one this past year, and it does work pretty well. But what we ended up moving to is this toolbar here with some coulters on it. So this toolbar has 3 20-inch fluted coulters. And that allowed us to scale up from a 1/10 of an acre to an acre of growing with the system. So the coulters they're climber coulters that they're available through AgriSupply. The toolbar is just 4-inch steel tube that a local metal shop welded together for us. And we've got an artist on our farm team, and we got her a few cans of spray paint, and she made it look really cool for us. The other thing with this that I really hemmed and hawed a lot about how to try to make transplanting easier in our second year of doing this. And what I decided to do was to get coulters that have these little knives on the back of them. Those knives are made to inject anhydrous ammonia into the soil. But my idea for them is that they would follow right behind the coulter. And I was hopeful that the coulters would cut a slit in the soil, and then the knives would loosen it up just enough to make it really easy to set a transplant in. So that's what we tried for this year of scaling up. And here it is. We put a little more weight on the back of it to have enough down pressure on the coulters to run it through the rye. And what we found is that the fertilizer knives, the coulters wouldn't consistently cut the rye. And so the fertilizer knives would really quickly get bound up with residue, and it became unworkable. What we did discover, though, is that just taking the knives off and only running the coulter discs through the residue worked really well. It makes a nice little slot. It loosens up the soil really well, and you can just follow through by hand and tuck in a transplant. So you can see this is what it looks like when we were planting some broccoli. And you can kind of see the soil. It's loosened up in just a little slot there. It's loosened about 6 inches deep. And so it's really easy to put your hand in that soil and pull it back a little bit and tuck the transplant in. So we're really happy with that tool to be able to do this on a little bit bigger scale than we originally started at. The other thing that kind of when you're planting into this, when we were doing it the first time, I felt a little worried because the soil feels really firm, and you know, when you're used to planting into tilled soil, it feels kind of like, is the plant really going to be able to grow in here? So this is just a couple photos of some fall cabbage that I pulled up, and you can see that, you know, even though the soil feels like it's really hard, the roots don't have any problem growing into it. And when the plants that I did dig up to check on them, saw really excellent root development through the soil. So weed management is another tricky, or just another thing that we learned about in this system. You can see this is some cucumbers that we planted really early, and you can see that this field in particular has really poor weed control in the initial rolled rye. In the foreground, you can just see really a lot of weeds growing up in there that would be very tedious to pull by hand. And so what we found is that these types of conditions, the poor weed control is correlated to a short tarping duration. So if you have the tarp on for just a very short time to kill the rye, and you're planting in soil with a high weed seed bank, it's much more likely that you'll have more weed issues in that field, at least in our experience. And then we also learned that applying straw as a mulch is an effective management strategy when weed emergence is unexpectedly high. It's much faster to go through and to have some straw bales to be able to just mulch on top of this in the, you know, in the critical couple weeks when the weeds are small enough and can be smothered by the straw. It's much easier to do that than it is to try to go through and pull all these weeds from the soil. So growing with this system, I'm always going to make sure that I have straw on hand for any types of situations like this where weed control isn't as good as I would expect. This field right here is a field of broccoli that was also tarped for a shorter time, and you may be able to see there's much of the rye in here is rolled away from the camera lens, but there is some straw that our team put on top of this broccoli for some of the small annual weeds that were growing in the understory. And after we put a little mulch on this field, we got really excellent weed control. And then this slide right here shows a field with no weed control at all. And this picture had a tarp on for maybe 4 or 5 weeks. And there's, you know, the occasional dandelion and occasional other weed growing up through here. But it's really neat to see with a system how little weeds actually grow in it. It's kind of remarkable. And then this is another photo here with some Brussels sprouts in it. Again, this field hasn't had any hand weeding, and there's weed control is excellent, but there is an issue in this field that you can see on the left with the poor stand of Brussels sprouts. And that is from the wet July we had this year and slugs. And it's just another challenge with this system because it creates very good slug habitat, especially during rainy weather. So that was something that I think I learned this year, that when I need to, a layer of management in the system is scouting and controlling slugs early. So this is what our initial 1/10 of an acre looked like the following spring. I was surprised to see the extent to which the residue had broken down. It was much more like an oat or an oat pea cover crop in the spring, really easy to incorporate into the soil. And you can see there's some sow thistle and dandelions, a few other perennial weeds in the system. Sow thistle's annual, but some, you know, dandelions and other perennial grasses. And I think for us, this system, I see the system not as a permanent no-till cropping system on our farm, but rather a way to rotate out of annual tillage. And so I think some of the advantages to that are, for us, tillage is a really effective way of controlling perennial weeds. And in these types of systems, we see really good control of annual weeds, but we also see a little bit of perennial weed buildup, especially dandelions. From back into a low-till system is I think an effective way for us to keep either perennial weeds or annual weeds from having the conditions that allow them to become dominant. And that's all I have for this presentation. This is a field of our fall kale this year grown on the system. And I'm interested in any questions that may have arisen.